Hello all, welcome to Docker Basics to Brilliance course. My name is Kastro Kiran. In the last video, we have understood what is meant by virtualization, what is meant by containerization, and what is the need for Docker that we need to use in the real-time scenarios, and what kind of problems it will solve in the real-time environment as a DevOps engineer. In this video, we are going to talk about two important concepts that are related to Docker. The first concept that we are going to talk is known as the evolution of containers. So how actually the containers have got evoluted over a period of time from each stage, passing the advantages and disadvantages of each and every stage that we are going to see. And then we are also going to talk about in-depth concept related to the containerization. In the last video, I have just given a glimpse on what actually containerization is. In this video, we are going to talk about the in-depth details of what is a container, what actually consists in a container, and what is the process of containerization. These are the two concepts that we are going to discuss in this particular video. So firstly, let us talk about how the containers has got evoluted over a period of time. That's simply evolution of containers. Usually, before the containers came into the picture, let us see how the container concept came into the real world scenario. So for that, let me take you an example here. Initially, we used to have a physical server. And then once we understood the importance of physical servers, and we also got to know there are some disadvantages with the physical servers. So to overcome the disadvantages of physical servers, then we have got the concept of virtualization. Virtualization has solved some of the problems which are being faced by the physical servers. But again, it also has its own disadvantages as well. So to overcome the disadvantages of virtualization, then came the next concept, which is known as cloud environment. Again, cloud is also something that is having its own limitations. And to overcome those limitations, then came the containerization concept, which is basically the Docker containerization concept. So we will talk about all of these concepts one by one, and we will understand what are the limitations, what are the disadvantages, what are the advantages of each and every one of these concepts. So firstly, let us talk about the physical servers. Physical servers will be available for every organization in order to deploy the application, or in order to take care of the application deployment process. We have to use these physical servers. Nowadays, once cloud came into the market, nobody is using, or at least few of them has shifted towards the cloud environment. Now let's see what are the disadvantages of the physical servers or on-premise locations. There are some limitations with respect to the physical servers. The first limitation is these physical servers usually have the high maintenance cost. So it's not that easy to maintain the physical servers because it needs the high electricity, and also it needs the cooling system. It also needs a separate set of team who takes care of the errors that might arise. And that's basically the hardware issues. So in the physical servers, we'll be facing too many hardware issues because of the compatibility things. In the physical servers, multiple applications cannot be deployed on the physical servers. It becomes a little challenging task in order to host the multiple applications in the physical servers. So these are some of the limitations of the physical server. So to overcome these limitations, then came the next concept, which is known as virtualization. Now, what is meant by virtualization? Virtualization is a process where we are going to use a software which is known as a hypervisor software. Now, let's say you have the hardware components and you have the host operating system. Let's say my host operating system is Windows operating system. On top of Windows operating system, I can launch the other types of operating systems, such as the Linux operating system and also the Mac operating system. If we want, we can use multiple operating systems on top of host operating system. So here, what is the host operating system? Windows is actually the host operating system. What are the guest operating systems? Linux and Mac are the guest operating systems. Now, how we are going to install Linux and Mac on top of the host operating system? So in order to do that, we are going to use a software which is known as hypervisor software. This we have understood in the last video also. So by using hypervisor software, we can launch multiple guest operating systems on the top of the host operating system. That's basically the virtualization. Now, what are the limitations of this virtualization? One major limitation with respect to the virtualization is the scalability is basically a major problem in the virtualization. So it's not that easy to scale the number of servers or to scale the capacity of the servers. That's one limitation. The other limitation is in the virtualization, the hardware components are completely fixed. We cannot change the hardware components according to our requirement. Initially, whatever the hardware components that we buy, using that hardware components only, we have to install the hypervisor software and then we have to install the guest operating systems. So to overcome these two limitations of virtualization, then came the next concept, which is known as cloud environment. So we have different types of cloud environment, like the AWS cloud, GCP, Microsoft Azure, IBM cloud. So we have the public clouds, private cloud, hybrid cloud. Like this, we have different types of cloud. Cloud is not having a major problem, but it has its own limitations. What are they? So the first limitation is cloud is something which is very much involved with respect to the cost aspect or with respect to the price aspect. So we know that once we keep on running the EC2 instances, we know the bill will get generated. And the bill that gets generated by running the EC2 instances by 24/7, it gives a huge amount of bill. That's actually only limitation that is available with respect to the cloud environment. But apart from that, there is no problem with the cloud environment. But however, to overcome this kind of limitation, that is cost aspect in the cloud environment, then came the next concept, which is known as containerization or containers concept. Now, what does it mean by containers? Usually in Docker, what we do is we will create the containers. Okay, we will create the containers. Now, by using containers, what actually we can do? So we can run multiple containers on a single virtual machine. So when containers concept was not there, we used to run multiple virtual machines. But once the container concept came into the market, by using one virtual machine or on top of one virtual machine, we can run multiple containers. That's actually the major advantage in order to save the cost of the application. And the second thing is these containers are actually, they are very light in weight. So they don't require a huge amount of the hardware resources. And because of this advantage also, we have got into the Docker concept. And these containers are very easy to maintain, and they're also easy to scale up or scale down according to the requirement. Now, inside the containers, what we are going to do is we are going to deploy the application. Okay, inside the containers, we are going to deploy the application. Let's see the containerization concept in a much detailed way in the next slides. So what is meant by container here? So container is something which is a lightweight, a standalone and executable package of software that includes everything which is needed to run a piece of software. It contains the code, it contains the runtime environment, it contains the system tools, libraries, settings, everything that is required in order to run an application. All the details will be available in the container. That's basically a container. So we know that whenever the port harbors or whenever the ship harbors are there, we used to see the huge containers. So in a container, we can place multiple things. Okay, we can place multiple things. Similarly, in Docker also, container is a place which contains the package of software. It includes everything that is related to the application. What does it mean by everything? Everything includes the source code of the application, runtime environment, the softwares that are required, the programming languages that are required, system tools, dependencies, libraries, settings, everything will be available in the container itself. So how they are going to be available in the container? We need to create the containers. Okay, we need to create the containers. How to create these containers? By using Docker. So containers are basically isolated from one another. So let's say on a single virtual machine, if you are installing or if you are running multiple containers, one container will not have any link with another container. So that's basically called as an isolated environment. And they run consistently across the different environments. If you remember, in the first video, we have talked about what is the problem of having the different environments. In the second video, we have discussed that, if I remember correctly. So there we have understood that in each environment, we have to install different set of packages, different set of softwares, different same versions of each and everything. So we have understood the difference between what actually the problem that comes arise when you are having different environments in the real-time scenarios. So to avoid that kind of scenarios or the conflict scenarios, we are going to use the containers concept. Let's look into the containerization definition. The typical definition of containerization is it is the packaging together of the software code with all its necessary components, such as the libraries, frameworks, dependencies, and all other required elements, so that they are going to run in an isolated environment, which is known as a container. This definition looks very typical, but let us understand this definition line by line and word by word in the next slide. So let's understand this containerization concept. Usually, whenever we are working with the Docker, we need to create these containers. That's the primary element whenever we are working with the Docker. In the Docker concept, containers acts as the most important element, because these are the containers that we are going to deploy and run on top of the EC2 servers or the EC2 virtual machines. Now let's look into this containerization concept. So as I was mentioning earlier, inside containers, we are going to deploy the application. Okay, inside containers, we are going to deploy the application. But in order to deploy the application, does containers have the predefined software? Let's say that, does containers have the operating system? No. So by default, containers will not have an operating system. So if the operating system is not there, is it possible to install the software? It's not possible. If we are unable to install the softwares or packages, is it possible to run the application? It is not possible to deploy the application, and it is also not possible to run the application. So here, what we need to understand is container is basically an empty element. It contains nothing. So whatever that we want to do, we have to manually deploy everything inside the container. Only then that particular container we can run on the virtual machines. Now here, in order to do this kind of thing, we are going to use a concept which is known as images, or you can also call it as Docker images. Once you have the Docker images, you will be having the operating system. You can install the packages, you can deploy the application, and you can run the application. So to run, deploy, and install any kind of things inside a container, it is mandatory to have the Docker images. Now, inside Docker images, what will be there? Inside Docker images, the operating system, the packages, the dependencies, everything we are going to include inside the Docker images. How to create these Docker images, we'll be discussing in the upcoming videos. But for time being, let us just understand the fundamental concepts of containerization. So as of now, it is very clear that Docker images are something which contains the operating system and also the packages which are required in order to run an application. Now, let's take it as an example. If you want to deploy an application on a container, what is the first thing that we need to have? We need to have the Docker image. Now, from where we are going to get the Docker image? We are going to get the Docker image from the Docker Hub, or we will create our own custom images also. So we can download the images that are already available in the Docker Hub or the Docker registry, or we can create our own images which are called as custom images. That is also possible. Now, images contains the operating system and the packages. What does it mean by operating system? It can be a Linux operating system, it can be a Windows, it can be Ubuntu, whatever the operating systems. But in general, we are going to use either the Linux operating system or the Ubuntu operating system on a large scale. Sometimes people will also prefer to use the Red Hat operating system and also Debian operating system as well. But on a large scale, image is something that contains the operating system and the packages that are required in order to run and deploy an application. Now, from the image, we are going to create the Docker container. Okay, from the image, we are going to create the Docker containers. Now, inside containers, we are going to deploy the application. Okay, inside containers, we are going to deploy the application. So that is how we are going to create the containers. So in order to create the containers, what is the first element that we need? We need to work with Docker images. In order to work with the Docker images, we need to make sure whether it is having or whether the Docker image is having an operating system and packages or not. Once you have the Docker image, by using Docker image, we are going to create the containers. Once the containers are created, then we are going to deploy our application onto the container. Now, where these containers will be available? Containers will be available on top of the virtual machines or the EC2 instances if you are using the AWS cloud. Now, these images actually acts as an operating system, and containers are something that are going to act as an application. So images contains the operating system and packages, so they acts as an operating system. Container basically contains the application. In order to create the container, in order to create the image, in order to deploy the application in the container, and in order to run the application in the container, we are going to use the Docker platform. So that is why Docker, we are going to call it as containerization platform. So by using Docker, we are going to create the containers. But in order to create the container, in order to create the image, in order to deploy the application, everything, if you want to do, we need to take the help of the Docker. Remember, Docker is a containerization platform. Now, containerization enables the application in order to run the application quickly and reliably from one environment to another environment without the need to install and configure the dependencies. This is what we were seeing in the last video. So if you have multiple operating systems or if you have multiple environments, what is the problem? You need to install the same version of the software in all the environments. That's basically a troublesome work for the DevOps engineers. So to avoid that, what we are going to do, we are going to create the Docker images. Inside the Docker images, the operating system, the packages, the software's dependencies, we are going to install. Once we install everything in the Docker image, we are going to share the Docker image to all the environments, and then we are going to deploy the applications in all the environments so that there won't be any problem of the code compatibility issues whenever we run the application. That's the concept of containerization. Now, the next question is how containerization will work. So we know that firstly, we have the hardware component, and then we have the host operating system. On top of host operating system, we have the container engine, which is also called as a Docker engine. On top of Docker engine, we are going to create the containers, and inside the containers, we are going to deploy the applications. Right, this we know so far. Now, how does containers actually work? So containerization is basically a technology that isolates the applications in a shared computing environment. Now you can see there is only one host operating system. On top of one host operating system, are we maintaining two containers? Yes, that's called as shared computing environment. And here, these two computing environments will act as the containers. Okay, they will act as a containers. And remember, one container will not have any link with another container. That means on top of one host operating system, we can run multiple containers. Okay, that is most important to understand. On top of host operating system or one host operating system, we can run multiple containers. That's basically because of the lightweight concept of the container. We'll talk about that in the next video. So here, the application isolation is completely possible in the form of containers. As I was mentioning, each application runs in a separate container, enabling multiple applications to coexist on the same server without any kind of problems. That is what we were just discussing. And then the containerization platforms. So what are the different containerization platforms that are available? On a large scale, we have only one containerization platform, which is basically Docker. And Docker is something that is currently booming in the market and which is also essential in order to become a DevOps engineer. Apart from Docker, we also have other kinds of containerization platforms as well, but they are all outdated, and we are going to use only Docker as the containerization platform. Now here, how to create a container image or a Docker image. Now, in order to containerize an application, we are going to use a software package which is known as Docker image. And this Docker image contains the application source code, the operating system, the libraries, configurations, dependencies, everything will be available inside the container image, or you can also call it as a Docker image. Now, once you get the Docker image, what is the next step that we are going to do? This Docker image, we are going to store in a public repository or a private repository. But here, public or private repository doesn't mean our GitHub account. So for Docker, we have a separate registry, which is known as a Docker registry. Usually, Docker registry is a public registry or a public platform or a public repository. Apart from public repository like Docker registry, we also have private repositories such as JFrog, Nexus are available. So we are not going to talk about the JFrog and Nexus in this particular course, but remember that in order to store the Docker images, we are having two options. One, we can store in the public repository or the public registry, or we can also store the Docker images in the private registry as well. The one common public registry that is available for Docker is known as Docker registry. So this is the place where we are going to store all the Docker images. Once we store the Docker images, then we need to deploy the code or deploy the Docker image, and we have to portable it. So whatever the Docker image that we have stored, we are going to deploy that in any environment where the Docker is installed. Make sure that Docker is mandatory in order to work with Docker images. So the stored Docker image can be deployed in any environment wherever the Docker is available or wherever the Docker is installed. And this actually facilitates the consistent deployment across various environments. Doesn't matter what type of environment you have. If you have the Docker image and if you are deploying the Docker image on an environment, there won't be any problem with the application to run. That's called as seamless working environment. So seamless in the sense, whatever the problems that are there in the previous scenarios, all those problems can be solved in order to work with the Docker image concept. That's how Docker images and Docker containers are going to help us to seamlessly work without any problem in order to run the application and also in order to deploy the application. Now, this uniformity ensures that application to function correctly regardless of the underlying system specifications. It doesn't bother about what kind of hardware components you have, what kind of host operating system you have. Once you have the Docker image, in the Docker image, everything will be available. So based upon the things that are available in the Docker image, we are going to create the Docker containers. Once we create the Docker containers, we are going to deploy the Docker containers on top of the container engine. Once we run the Docker containers, we are going to get the application. So this Docker containers, again, we have to deploy in the Kubernetes cluster. And in the Kubernetes cluster, we are going to run our application. But this particular course is purely related to the Docker. So we are going to focus in-depth concept related to the Docker, keeping aside the concept of the Jenkins and also the Kubernetes. But anyway, we are going to see one project which is related to the integration of Docker with GitHub, Jenkins, and Maven. That we will see at the end of this course. Now, to keep it in a nutshell, containerization is something that streamlines and secures the deployment of application, which is going to offer an efficient and conflict-free environment in order to ensure the application to run in a better way across the different environments. That is all about the containerization concept. So I hope you got an idea about what is meant by a Docker image, what is meant by a Docker container, and what is meant by the concept of containerization. So this is all about that we need to discuss in this particular video. In the next video, we are going to talk about some of the other advanced concepts that are available in the Docker course. Thank you.